Language, in its many forms, serves as the scaffolding upon which we construct meaning. Just as a building relies on a framework to support its structure, so too does our understanding of the world depend on the systems of language we use to describe it. Whether we're talking about the intricate syntax of computer code or the nuanced grammar of human languages, these systems provide the underlying structure for communication and thought. Consider the way a computer program functions. At its core, code is a set of instructions written in a precise, unambiguous language that a machine can understand and execute. These instructions are built upon a foundation of predefined commands and data structures, forming a system of rules that governs how the program behaves. In essence, code is a language that allows us to communicate with machines, instructing them to perform specific tasks. Human language, while seemingly more fluid and less rigid than computer code, operates on a similar principle. We rely on a shared system of grammar, vocabulary, and syntax to convey meaning to one another. The words we choose, the order in which we arrange them, and the subtle inflections we employ all contribute to the overall message we're trying to convey. Like code, language provides a framework for understanding and interpreting the world around us. Both code and language are built upon systems of rules and relationships that allow us to express complex ideas and concepts. These systems, while distinct in their specific implementations, share a fundamental similarity in their role as facilitators of communication and meaning-making. Understanding the nature of these systems is crucial to unraveling the intricate ways in which we use language to navigate the world. At the heart of both computer code and human language lies the concept of recursion, a powerful mechanism that allows us to build complex structures from simpler ones. Imagine a set of Russian dolls, each nestled within a larger version of itself. Recursion works in a similar way, with elements referencing and building upon themselves in a seemingly infinite loop. In computer science, recursion is used to create elegant and efficient solutions to complex problems. A function can call itself within its own definition, creating a loop that repeats a set of instructions until a specific condition is met. This allows programmers to break down complex tasks into smaller, more manageable subproblems, making code more modular and easier to understand. Language itself exhibits recursive properties in its structure and use. Consider the way we define words. Often we find ourselves using other words to explain the meaning of a particular term, creating a chain of definitions that can feel circular at times. For example, we might define joy as a feeling of great happiness, but then need to define happiness itself, perhaps as a state of contentment and well-being. This recursive nature of language is not a flaw, but rather a feature that allows for incredible flexibility and expressiveness. Just as a single Lego brick can be combined with others to build an endless variety of structures, so too can the building blocks of language be arranged and rearranged to create an infinite array of meanings and ideas. Imagine standing between two mirrors placed opposite each other. You see your reflection, not just once, but repeated endlessly into the distance. This visual illusion serves as a powerful metaphor for the recursive nature of language, where words are often defined by other words, creating a seemingly infinite regress. Consider the word justice. We might define it as fairness or righteousness, but then we're faced with defining those terms as well. Fairness could be understood as impartiality or equity, while righteousness might be defined as moral uprightness or virtue. Each definition leads us down a path of further definitions, reflecting back on themselves in a dizzying spiral. This self-referential quality of language is not a limitation, but rather a testament to its remarkable flexibility. Language is not a static system with fixed meanings, but rather a dynamic, ever-evolving tool for making sense of the world. As our understanding of concepts changes and evolves, so too do the words we use to describe them. The infinite mirror of language reflects the boundless potential of human thought. It allows us to delve into the nuances of meaning, exploring the interconnectedness of ideas and concepts in a way that would be impossible with a finite set of definitions. The recursive nature of language leads us to a fascinating paradox. How can we define something in terms of itself without creating a circular argument? If a word's meaning ultimately relies on other words, which themselves rely on still other words, are we doomed to chase definitions in an endless loop, never arriving at a truly fundamental understanding? This paradox highlights the limitations of language as a tool for capturing the essence of reality. While language excels at describing relationships and connections between concepts, it struggles to grasp the fundamental nature of things in and of themselves. The meaning of a word is not inherent in the word itself, but rather emerges from its place within the larger web of language and our shared understanding of the world. Consider the classic example of trying to define the color red. We might describe it as a primary color, or perhaps as the color of blood or fire. However, these descriptions rely on prior knowledge and experience. Someone who has never seen the color red would not be able to understand its essence from these definitions alone. The paradox of self-reference reminds us that language is not a perfect mirror of reality, but rather a tool that we use to navigate and make sense of the world. While we may never fully escape the circularity inherent in language, recognizing this limitation allows us to appreciate the incredible power and flexibility of this tool that we so often take for granted.